Okay, so in this video, we're going to look at sketching a function using all the information that we've learned so far. So what we're doing is we're just kind of putting it all together to sketch a function, which is the original reason we do what we do. Okay, so I think on your notes there is a typo, and this should be 4x squared minus 3x minus 1, not 4x cubed. So when we get ready to sketch a function, we want to look at its domain. You should recognize this as a parabola and see that the domain will be all real numbers. Because it's a parabola, it doesn't have a horizontal asymptote or a vertical asymptote. But it does have zeros, so to find the zeros we could factor this, 4x and x and 1 and 1, and I need it to be negative, so that'll be plus. So it has zeros at x equals negative 1/4 and x equals 1. To find the y-intercept, we set all of these equal to 0, so we get the y-intercept is 0, negative 1. Some of this may or may not be in your notes. So we always want to start by finding the derivative. So the derivative of this function would be 8x minus 3. And the second derivative, of course, would just be 8. So using this information, we're going to find the critical numbers. So the critical numbers happen when we set the derivative equal to 0 or when the derivative is undefined. Now, we want to know if this is a max or a min. So to determine if it's a max or a min, we do a sign chart. We take a number slightly smaller than 3/8, which we could say 0, and we put it into the derivative, and we see if we put 0 in for x, we get a negative. If we put a number greater than 3/8, let's say 2, we get a positive number. So that means that it went from negative slopes to a positive slope, so we have a local minimum. And to find that local minimum, we put that value into the original function. So the intervals where it's increasing or decreasing, because the slopes are negative here, would go from negative infinity to negative 3/8. I'm sorry, to positive 3/8. We would say that it is decreasing. And then from 3/8 to infinity, we'd say it's increasing. And to find that minimum, we would put 3/8 back into the original equation. I need to find that original equation. So this would be 4 times 3/8 squared minus 3 times 3/8 minus 1. And did I get a value for that? I don't think I got a value for that. Well, you could use your calculator to figure out what that is. To get a point of inflection, we would take the second derivative. So set the second derivative equal to 0. So the second derivative is 8. So this has no point of inflection because the derivative is always positive, meaning that the curve is always concave up. So it is concave up all the time. What else do we need to know? Okay, I think that's all we need to know. We do need to know what this minimum value is, and I don't have a calculator, but you would figure that out so that would be 4 times 9 times 64 minus 9/8 minus 1, and I have no idea what that is without a calculator. Okay. But we would graph it sort of like this. So we'd look at the zeros. So we said that there was a 0 at negative 1/4 and 1. Negative 1/4 and 1. There is the maximum or the minimum is at 3/8. that correct? And again, we would use whatever value that is. I don't know what value that is. I'm just going to kind of put it somewhere. And we know that it's always concave up. So this graph would look sort of like this. And we know it looks like a parabola, so it'll be a little bit rounder. I'm just not very good. This drawing on this thing is very difficult. So I apologize for that. So we have a 0 at 1, at negative 1/4. The minimum is somewhere at 3/8. And so it looks sort of like this. And it's always concave up. And it looks like a parabola. Sorry that looks so crappy. Okay, so that is kind of how we would sketch that. Come back and watch video 2.